Welcome back to Applied Algebra. So previously we finished chapter 9, which dealt with systems, and now we're moving into chapter 10, which is factoring algebraic expressions, which leads us into some other information. So we're going to start with section 1, which is finding monomial factors. So some terms we need to think about. One is the term monomial. So monomial, you think of the word mono here. Mono means one. And so when we're talking about monomial factors, we're thinking of what is one item that I can take out, but these have in common. So they're going to have one common term. And that's what I'm going to try and take out of them. So one of the ways that we can do that is to break it down and show each individual part. So for instance, what does really x squared mean? X squared is x times x. That's what x squared means. And then 7x is 7 times x. So this is a binomial, right? I have two terms, the x squared and the 7x. I've broken them down into what their parts are. Now you want to ask yourself, what parts do they have in common? This has an x, so does this one. Now the leftovers though, the first term has an x, but the second term does not have another one. The second term has a 7, but the first term does not. So the only thing they have in common is 1x. So that 1x is going to be taken out. So the front number or the front letter is what they have in common. Now in parentheses I'm going to put the leftovers. So if I take the circled x out, what's left in the first term? I have one more x. If I take this circled x out of the second term, what's left? I have a 7 left. So this is factored. I took a binomial and I factored it into two terms. I have a monomial, which is my first term, and I have a binomial, which is my second term. We're just focusing on taking out monomials. We're not worried about what's left over. Okay, but we will show us what's left over. So let's break down what this means. 10x squared. 10x squared, 10 is 2 times 5, and I want to try and break it down into things that are prime. And then x squared is x times x. 5 is 5 times x, because 5 is already prime. So I have to ask myself, what do they both have? I see a 5 in both of them. I see an x in both of them. So since they both have a 5x, I write that in the front. Remember, the front is what they have in common. Now I put what's left over. So I have a 2 and an x in the first one, plus, now everything came out of the second term, but I can't leave this blank, because if I start with a binomial, my factor here in the parentheses also be a binomial. So I have to think, what can I place here that would not change the value of this 5x? Well, 5 can be multiplied by 1. 5x times 1 does not change the value. So I can say there's a leftover 1 there, so that I still have a binomial inside, which because I had a binomial to begin with. So anytime you take out all the factors, leave a 1 in that position. Excuse me. Now the more you practice this, you won't necessarily have to break things down into primes. So what I notice right away here is 10, 10, and 10. They're all jumping out at me. So this is 10 times x. That looks bad. Let's try that again. So it's 10 times x plus 10 times y minus 10 times z. So we're going to ask ourselves, what do they have? Well, they each do have a 10. I could have broken it down into 2 and a 5, but I would have put them back together. Now, do they have any letters in common? The first one has an x, the second one has a y, and the third one has a z. So they have no letters in common. So what's in common goes in the front. Now the leftovers go inside. I have an x left, I have a y left, and I have a z left. I started with 1, 2, 3 terms. I ended with 1, 2, 3 terms. So I have to make sure I do that. And I do not know where. Oh, that was my plus sign. kind of got ruined. Okay, so start with 3 terms, end with 3 terms in the parenthesis. The next one, 90r squared minus 10r squared. Do note that the first r is lowercase and the second r is uppercase. R's that are different cases are different variables. It's no different than if this was a and b, x and y, whatever. So 90, I know, is 9 times 10 times little r times little r. 10, I'm just going to say, is 10 times big R times big R. So what do they have in common? I see a 10 in both of them. I do see r's, but remember they're different cases, so they are different, and I don't see anything else. So 10 is the only common term, so it's all that's going to go out front. I have a 9, and I still have 2 r's, so I'm going to go ahead and put them back together. Don't have any numbers left here, but I do have the 2 capital R's. Started with 2 terms, I ended with 2 terms. 36, 18, and 54. So here's where knowing your number facts comes really handy, because I really don't want to break 36 down all the way into its primes. With small numbers, that's not a big deal. So I'm going to think, what does go into 36, 18, and 54? Well, 36 is divisible by 6. So 6 times 6 is 36. 6 times 3 is 18. And 6 times 9 is 54. Now, what I should have done is put my letters in there. I kind of forgot them. So the first one has 2 y's. The second one has 3 y's. And the last one, 6 times 9, and it has 4 y's. Now I started this by noticing that 6 went into all of them. So they all do have a 6. Here's 1 y. They all have another y. At this point, the first term doesn't have any more y's, so I can't take any more out. But I'm looking at the 6, the 3, and the 9, and I'm like, those have something in common. The 6, the 3, and the 9 are all divisible by 3. So I'm going to go ahead and break this 6 down into 3 times 2. This is just 3. This would be 3 times 3. So I can see that they each also have an additional 3. So there is a, if I don't go all the way to primes, I might have to do it after the fact. So let's see what's in this first term. I have a 6 and a 3 in common and 2 y's. Right? In every one I have a 6, a 3, and 2 y's. A 6, a 3, and 2 y's. So that's my common. 6 times 3 is 18. Y times y is y squared. So now let's see what's left over. Remember, the 6 here changed to 3 and 2, so I really just have a 2 left over there. And I circled all my y's, so I have no y's. I circled the 6 and the 3. I circled those 2 y's, but I have a y that's not circled. This 9 changed 3 and 3. I do have a 3 that's not circled. And I have 2 y's that are not circled. So I started with a 1, 2, 3 term by a trinomial. I have 1, 2, 3 terms. And if I look at this, 2, 1, and 3 have nothing in common besides 1. And there's not a y in every term, so I have gone all the way down. Okay, so number 6 looks a little crazy. It just has more parts, so you just have to be diligent about making sure you do all the parts. So what goes into 15, 20, and 5? I'm thinking 5. So 15 is 5 times 3. I have 2 x's, 1 y, and 4 z's. 20 is 5 times 4. I have 3 x's, 2 y's, and 2 z's. 25 is 5 times 5. I have 2 x's, 3 y's, and 2 z's. Okay, I've written it all out, so let's see what they have in common. I see that they each have a 5, so I'm going to circle that. They don't each have a 3. I see an X in each of them. And they each have another X, so I can circle the second X. Do they each have a Y? Yes. Now this one's out of Y's, so I'm done with the Y's. I do see a Z in each one. And in fact, I can still circle another Z. But these last two terms are out of Z's, so I can't circle any more Z's in the front. So there's nothing that's left uncircled that is in all the terms. Everything else is not in every term. So what is circled? I have a 5 circled. I have 2 X's circled. I have a single Y circled. And I have 2 Z's circled. It's uncircled. I have a 3 and 2 Z's in the first one. I have a 4, a single X, and a single Y in the second term. And I have a 5 and 2 Y's in the third term. I started with 1, 2, 3 terms. I ended with 1, 2, 3 terms. Okay, so practice that section. You're always going to end up with just a monomial in the front, and then the parentheses should be the same size as your original problem. If you have any questions, let me know. Have a good day.